All right, we're live. We can do it.
Let's do this. Let's just start with part 2.
Yeah.
So what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? You just need to make sure that it's a simple random sample and it was drawn from the population. That the mean is normally distributed. And that the standard deviation is assumed.
To be known. Sweet.
Assumed to be known. Yeah.
All right. Number 7. What's the point estimate for the population mean?
541.
541. Okay.
Gives us. Yeah.
kind
And then
problem.
Create a 95% confidence interval for the population mean.
So this is just 2 standard deviations away from the mean, correct?
Yes.
Yes.
Okay, so the standard deviation is... 32.
It's not quite 2, it's 1.96.
96. Yeah.
Okay. See, I've always just used 2 because that's what I always remember being taught, so...
Yeah.
My numbers might have been slightly different, but...
Well, we were originally taught that it was 2, but now this chapter has changed to 1.6
okay.
now.
You said to use the applet to figure it out. Just type it in, it should give you. Yeah, so then we do the I'm drawing a blank.
We use that formula to to get basically the plus or minus
the margin of error
or whatever.
Margin of error is what you were looking for.
Yeah, I'm so blanking.
The
margin of error formula. So we do 1.96 times 32 divided by 50, the square root of 50.
Yeah.
Yep.
So does that give us 8? I got 8.87.
Yep.
Okay.
Plus or minus from 541.
Yeah.
Yeah, so 532 to 0.13 to 549.87.
Yep.
Yep. Okay, and then...
So how do we do that again? Sorry.
Oh, you're fine. So you do the margin of error formula.
Okay.
So that's the margin of error times or equals the standard deviation, which is 1.96, and you times that by the standard deviation, which is 32, divided by the square root of the number, which is 50.
Okay, cool.
And then you plus or minus that from the number.
That makes sense.
So we got 8.87, so you do 541 plus 8.87 and 541 minus 8.87. It should give you the...
That's super easy. Okay.
Yeah.
Okay, and that's super easy.
So 9's the exact same thing, but you just put 100 in instead of 50.
Yep.
So I got 534.73 and 547.27 for the top.
Yep.
All right.
Cool.
All right, and then number 10.
It just got smaller.
Yeah.
Yep.
The larger the sample size, the more likely you'll be close to the mean.
Yeah.
Yep. Okay, number 11. Sorry. Create a 90% confidence interval for the origin of 50 students. So that you go and you type in 90.90 in the applet, and it gives you 1.645.
Yep.
And then you do the same thing. You plug that into the formula, and I got 7.444.
Yep.
Okay.
Plus or minus.
And plus or minus that from 541, so you get 548.44 and then 533.44. 5.6,
Perfect.
Yep.
right?
5.6. Yep.
Or 5.56, yeah.
Yep.
Okay. And then number 12. So how is it compared to?
The 90% confidence or margin of error is smaller than the 95%.
Mm-hmm.
Right.
So
Yeah.
so the smaller the margin of error gets, the level of confidence gets smaller, correct?
Yeah.
Is that right?
Yeah, which I think is kind of
Yeah.
interesting.
Yeah. All right, and then this one, number 13. So he gives you the margin of error, and you have to find the number of students that it would get. So then you plug in that formula. The n
Yeah, just do
equals
that.
z times the standard deviation divided by the
Divided by
margin of error,
margin of error
all
squared. Yeah.
Yeah.
And I came out with 158 students.
Yep.
Yeah.
Oh.
So do we round
Yeah.
up regardless? Because it was 157.35.
Yeah.
And we just round up.
Yeah.
So
Even
then
if it's
Yeah.
157.1, yeah, it was pretty.
You round up to
Yeah.
158. Okay.
Yeah.
I just want to make sure. Okay.
All right.
Should we do the quiz?
Yeah. Let's tackle it.
Yeah. Okay.
I need to open up the applet.
I know.
I always forget to do that every time.
Okay, so standard deviation is 50 divided by square root of 25. So the 90% is at 1.645.
Yeah.
Yeah.
Is that what you guys got? Okay.
Okay.
So 50
And then 50 divided by the square root of 25 is
plus
just 10.
25.
Just 10, yeah.
Okay.
So it's just
Times- Oops.
1.645. So I got 16.45.
Yep.
0.450
0.45.
Yeah.
because she wants 3 decimal places.
Yeah. Yeah.
Okay.
So with that, real quick though, I just want to make sure when we find, sorry, let me find where that's at. The 90%, we put that in the z-score as 0.9.
You put it in the area. You put it in the
Okay.
area and only shade in the middle part
Okay,
and not
so
the side. So just shade in the middle, and then it should give you the z-score on the bottom.
and that's the 1.645, right?
Yep.
Yeah.
Yeah.
Okay. And then from the rest of that is just you multiply the z-score times the standard deviation divided by the square root of the value, right?
Yeah.
The n?
Yep. Yeah.
Okay. Really easy. Okay.
Okay. All right. Which of the following statements is true?
So real quick, what did we get for the margin of error?
Oh, no, you're fine. It's 16.450.
Okay, that's sorry, my phone the internet keeps cutting out.
No, you're fine. Number 4. Which of the following statements is true? Point estimator of the mean. Isn't it one of the mean ones?
I think mu is a
Yeah.
point estimator, but I can't remember. I'm looking at it.
Yeah, I did the control F for point estimators, but it doesn't really flat out say that. But they kind of say that in a way at the bottom of the 3.1 section.
Yeah.
The point estimator is just the number used to estimate a parameter. Yeah.
So
So which one is it?
I'd guess A, just based off of what I'm reading.
yeah, that mu is the point estimator of the
That's
sample mean, or the x.
X with the line. Okay.
Yeah,
Yeah.
because it says point estimators are just one number that's used to estimate a parameter.
Yeah, and interval's a range of numbers, but neither of the interval estimators make any sense at all. So.
Okay.
What does that U stand for again? I always forget.
So that's the mean.
Mean. Okay.
The sample mean.
The population.
That's the population mean. Sorry.
Yeah.
Okay. So that's why I get confused because there's multiple things that have mean in the word. So.
Yeah.
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 All right. Number 5. Gina wants to construct a 95% confidence interval. Okay, use this information for 538. What's the lower limit of the confidence interval? So this one we do the margin of error, and then we just minus it from 526, right?
Yep.
Yeah.
So the 95 is 1.96.
So did you get 498.315?
Yep.
Cool. Yep.
498.315.
And the upper limit, you just add to the 526, right?
You minus, because
Yeah.
they want the lower level.
Yeah, the upper one.
No, for the upper limit. Sorry,
Oh, sorry.
for number
Yeah.
6.
Okay, yeah. So the lower limit is 498.315, right?
Yep.
Yes.
Yep.
Okay. And then the lower level is, or upper level.
Oh, crap.
Is it 553.685?
Yeah, that's what I got.
553.685.
That was 685, yeah.
Okay.
Okay, what would happen to the width of the confidence interval if Gina increased the sample size?
It should
That's
decrease,
a
right?
Decrease?
Yeah.
Yes. What would happen to the width if she changed it to a 99% confidence interval?
It should increase.
Increase.
Yeah.
Okay. Number 9. Okay, so this one we do the sample size.
Yeah.
So you type in 95. Oh, well, we already know
So
these.
1.960
1.960
times by
times
400. Divide that by
100.
square it. So 246 is what I got.
How do you do this one again? Sample size. There it is.
So
is
it's
it
the z-score times by the standard deviation, and then instead of dividing that by the square root of n, you divide it by the margin of error, and then square everything at the
square the
end.
whole thing? Okay.
Yeah.
Did I lose you guys for a little bit?
Yeah.
I think so. We're on number 9.
Yeah, I number 7 was decrease, right?
Yep.
Yeah.
And then 8. What do we get for 8?
Increase.
Increase.
And now we're working on number 9.
Yep.
Okay, and then we have to round to the nearest whole number, so it's 246, right?
Yep.
Is that what I got?
So let's see. So wait, is our z-score is the 1.96 in this case is 95, right?
Yeah.
Times the 400 divided by the 50, because that's our margin of error. And the whole thing is
Uh-huh.
squared.
Yes.
You,
Yeah.
And then
Yeah, squared.
246.
Yeah,
Yep.
rounded up 246.
Okay. Okay. That's not that bad. Okay. Oh boy.
Okay, so for number 10, I got, shoot. So I got the mark as 11,998.467. Is that
Yeah.
right?
Round to the nearest whole number. So that for 11,
okay.
that should be for number 11 because that's the upper limit.
Okay. It says the same thing on number 10 too. Round to the lower limit too.
Yeah. So for the lower limit, I got 88,002.
Okay.
88,200 or 2?
88,002.
Okay, 88,002.
Yep.
Okay.
Wait, aren't we supposed to go off of 111,000?
I don't think so.
Because it says you collect a sample random of 36 women's salaries and find that the mean is 111,000.
Yeah.
Do
I
we use
kind
that one,
Yeah,
or
I
do
think
we,
you have
or
to
do
use
we use
100.
100,000?
100,000.
I think you use the 100,000 and then like if we were to try to like see if we accept the p value or not, then we have to use the 111,000.
Okay. So it's 88,002.
Yeah. I think so.
Okay.
I don't know. I haven't
Yeah.
found any.
Yeah, I'm not too sure. But I don't know. From what it sounds like we use 111,000 based on the way the question's worded.
Yeah. Let's see where I'm trying to find in the homework or the reading if they did any
Of these, like, yeah,
yeah.
population mean versus sample mean.
Okay, in let's see.
So it says you're interested in the mean salary for women from the population mean.
So in the hospital one, at the kind of the very bottom, they use the sample mean, not the
Not the
not
population.
population mean. Yeah. So.
So 111,000.
So 111.
Yeah.
So it would be 99,002.
Yeah.
99,002 for the lower limit, and then
You just add 11,000 to each.
Yeah. So this one's 122,998.
Yeah,
122,998.
Yeah.
I got it.
Are you guys putting commas in these?
I am.
Okay, I am too. Just making sure. And then number 12. There are 3 requirements needed, and isn't it all of the above?
I think so. Yeah.
Yeah.
You have to have the sample random drawn from the population. The mean is normally distributed, and the standard deviation is known.
Yeah.
Okay. Yes, or it's assumed to be known.
Yeah.
Okay, so did everyone get everything?
Yeah, I think so.
Yep.
All right, I can turn it in.
Okay.
Oh, we missed number 4. So it's the
The other way around?
Yeah, it's just opposite. So the
uh,
mean is the point estimator of the other mean.
Of mu. Okay.
Yes. So it's the sample statistic is the point estimator for the population. And then that's the only one we missed. Just number 4.
Okay.
So we. Yeah. Oh, Joe is not on here.
Oh, did he get cut off?
I guess so. You know, I wasn't seeing it, so we'll wait till hopefully he can get back on.
Yeah.
I thought he was kind of quiet.
I know, I thought so too. I wonder if I have to invite him again.
Might as well.
Yeah.
Okay. I know his internet was cutting out.
Yeah.
Huh. I don't know. I am not quite sure what to do.
Yeah. I'm not sure if he's going to be able to come back.
I know. Send out another invitation, but I don't know.
Well, he's been cut out before and was able to get back in, right?
Yeah. Yeah.
Maybe his internet's just. Do we need a? I wonder how much he missed.
I know, that's
Yeah.
what I'm wondering too.
Because he was here for 7 and 8, I think, and
Yeah.
9. I think he just missed the last 3. So
10, 11, and 12.
so we could email him or something with what we got on it, and then.
Yeah.
In addition to number 4 being wrong.
Yeah.
Oh yeah. Yeah.
Alright. Do you mind doing that, Chris?
Yeah, I'll email him really quick.
Okay. Sounds good. And then, yeah. And then we'll just meet on Wednesday?
Yeah, Wednesday, 8:15 again.
8:15. Yep.
Yeah, that's fine.
Okay.
Okay.
All right.
Sounds good. Okay. Thanks.
See you guys.
Yep, see ya.
ya.